Okay, so for Calculus Chapter 2, number 6, we've got this function and we're supposed to draw a graph that satisfies all of these properties of limits. So let's take a look. So the first part says, as x goes to 2, the y's approach negative 1. So let's draw some axes. So as x gets close to 2, 1, 2, the y values get close to negative 1. So that means that coming from this side and coming from this side, I get close to 2. Or sorry, get close to negative 1. And that's all I know. I don't know if that dot's filled in or not. I just know that at least this much has to be true. As x gets close to 4 from the right side, then y shoots down to negative infinity. So from the right side, I have to go down to negative infinity like this. From the left side of 4, I have to go up to positive infinity, so that's something like this. As x goes to infinity, then y also goes to infinity, so that's going to do something like that way out at the end. And then lastly, as x goes to negative infinity, the y values go to 2. So here's 1, 2. Way out here, the function does something like this. It looks like y equals 2. So really at this point, we're just going to connect everything. So let's do something like this. Whoa. Sorry, the pen is not working well. There we go. Oh, it's brutal. Okay. So then the next question says, is it possible to find a function that satisfies all of these conditions and is continuous everywhere? Well, this dot right here, we don't know if that's filled in or not. So if it was filled in, then at least it would be continuous there. The other thing is, though, that I've got this vertical asymptote no matter what. And so there's always going to be an infinite discontinuity right here. So no, it's not possible to have continuous everywhere, right? No, not possible. Is it possible to find a continuous function? So that means continuous on its domain that satisfies all these conditions. Well, yeah, sure. The one that we drew, 4 is not in the domain because I can't plug in x equals 4. 2 is not in the domain. So, but it is continuous everywhere else. So in this case, is it possible to find a continuous function? Yes. Okay, hope that helps.